Today we're continuing covering factoring polynomials and solving using the zero product property. In the first lesson that we covered this, we factored and applied the zero product property separately. Today we're going to put them together. So let's take a look at our first equation. 2x squared plus 8x equals 0. So our first step in solving this is to factor. So what's our greatest common factor on the left-hand side? Well, they both have 2 in common. 2 goes into both 2 and 8. And they both have an x. So we can factor out an x. When we divide 2x out of 2x squared, what are we left with? X. And when we divide it out of 8x, what are we left with? 4. So remember that by applying the zero product property, we know that 2x must equal 0, or x plus 4 equals 0. Because if you have a product equal to 0, then one of the factors has to be equal to 0. So if 2x equals 0, then x equals 0. If x plus 4 equals 0, then x equals negative 4. Those are my two solutions. And I can check by plugging them each in individually up here in my original equation. Sometimes we'll start with the terms on opposite sides of the equation. So our first step is to move everything to one side by subtracting 15n from both sides. The next step is to factor. So what goes into both 6 and 15? 3. And what else do they have in common? n. Now when I factor 3n out of the 6n squared, I'm left with 2n. When I factor it out of the negative 15n, I'm left with negative 5. Again, applying the zero product property, I have 3n equals 0, or 2n minus 5 equals 0. The one on the left gives me quite easily n equals 0. The one on the right is actually two steps. 2n equals 5, so n equals 5 divided by 2. There's my two solutions. So one type of real-life equation we can use quadratics or polynomials to solve is the vertical motion model. Height equals negative 16t squared plus vt plus s. So this represents your height at any time t. T squared and t, of course, represent time. V is initial velocity, which applies if the object is thrown or launched by some method. But if you drop it, there's no initial velocity because there's no added force. And S is your starting or initial height. Now we're told that a startled armadillo jumps straight into the air with an initial vertical velocity of 14 feet per second. After how many seconds does it land on the ground? So we would set up our vertical motion model as h equals negative 16t squared. And since its initial vertical velocity is 16, that goes in, or sorry, not 16, 14, that goes in for v. And since it starts from the ground, its initial height is 0, so we don't have anything to add there. Now, since we want to know how it lands, or when it lands, we want to know when its final height is 0. So we want to solve this equation, which we can do by factoring. What do the two have in common? 2 and t. When we factor out 2t, we're left with negative 8t plus 7. So I have solutions when 2t equals 0 and negative 8t plus 7 equals 0. Solving those gives me t equals 0 and t equals 7/8. Now t equals 0, that's the starting time. That's when the armadillo jumped. T equals 7/8, that's how long it takes for the armadillo to land. So it takes 0.875 seconds. That's just 7 divided by 8. Alright, how about you try one on your own? 3s squared minus 9s equals 0. Give that a shot, and then unpause the video and see how you did. So we want to look at first what they have in common. 3 goes into both 3 and 9, and they both have an s. Taking 3s out of 3s squared leaves us with s, and dividing it out of negative 9s leaves us with negative 3. So we have solutions when 3s equals 0, or when s minus 3 equals 0, which gives us s equals 0 and positive 3. There's our solutions. Alright, if you have any questions, feel free to ask. If not, you can move on to your homework.